Today we will have a review of our 5 classes, excluding the first 2, which I introduced quantum in a cartoonist point of view, and the another second one that is on the philosophy of the subject. But that 2 classes, we can say warm-up classes, we can exclude from our review part and of course from the exam part. But then third class onwards, of course they are very much part of our syllabus, and we will review those things only in question answer format. And one thing, let me declare that I am not quite sure that in what fashion college or university is going to conduct the exam. Hopefully it would be an online exam again. So in that case, I'm not quite sure who will be the paper setter, but whoever the paper setter is, assuming that if I happen to be the paper setter, then what would be my set of questions, particularly keeping in mind that the way I have conducted the classes, the way I have covered the topics, so naturally my question would be from my coverage if I happen to be the examiner. So in that case, you can safely say that whatever the questions that we will discuss today will be the syllabus kind of thing, I mean bank of questions kind of thing. In PG level it is not advisory to give a question bank kind of thing, but as it happens in PG level also, that whatever the teacher teaches, he naturally sets the questions from that portion only, isn't it? So in that spirit, today I will be discussing the questions and answers, and all the questions are actually you have already come across, right? You have gone through in the last 5 classes. So just today we will be reviewing it only. So let me go to the first page of the PowerPoint file. So all the questions are given. In the first page there are 8 questions, and we will interact. Okay, some of the hints in some questions I will give you some hints. You have to do it on your own later on, and some of the conceptual things that we discuss, and some of the questions are so common and popular that it can be given as task or exercise, and that too already has been discussed in the earlier classes. So for example, question 1 reads like, why quantum mechanics is also called as wave mechanics? So that we have discussed, right? Would you like to make any comment, any one of you, that as an answer to this? Let me go for the second question. So that the ionization energy of hydrogen atom is 13.6 electron volt. Basically it's a 11-12 question, class 11 question, where Bohr's model is there, and you know the energy expression, so you know the delta E expression, say 2 levels N1 and N2, you have some expression including some constant values, and then if you put one of the quantum number infinity and one of the quantum number 1, then you will get the energy difference delta E, and which is nothing but the ionization potential, because one of the quantum number is infinity. That means you are ejecting an electron from the orbit, first orbit, to the infinity. So you will get the value 13.6 electron volt. So that the third question, so that the reduced mass of hydrogen atom is a number times mass of electron, Me. That means slightly less than the mass of an electron. So this question actually demands that you have to have the knowledge of what reduced mass is of a system, at least for 2 particle system. So hydrogen atom is really a 2 particle system, 1 proton at the nucleus and 1 electron. So 1 proton and 1 electron, so 2 masses, and you know reduced mass is defined as m1 m2 by m1 plus m2. So if you assume that a mass of proton is how many times that of the mass of electron, you just put it and you will get 0.9995 mass of electron. Okay. So basically these are the HS level question. Remark on the simple looking relation P equal to H by lambda. Just the question is, you have to make some remark. First of all, your comment may start that it is the famous de Broglie relation. Now, second point, it is a bit awkward and very peculiar relation because it connects two concepts in a single equation. P, particle, mass into velocity, momentum, and lambda, wavelength. So it is a unique relation that combines two different aspects of the same entity, the particle character and the wave character. And third point, one of you told that for small particle, no, it's for any particle, but it is significant if the particle is small. Otherwise, the wavelength you will get if you calculate using momentum, that means mass into velocity for that big particle, then you will get actually small lambda, so small that it is not significant or not comparable at all to the size of the particle. But when the particle itself is small, then even the wavelength is small, but it is comparable to the original system. So then in that case, we cannot neglect either the particle aspect or the wave aspect. So that means the wave aspect too becomes important for small particle. But the relation is very general, it is valid for each and everything. Okay. So the next question, what do you mean by atomic mass unit? That you have to tell. And what is the value of Planck constant in atomic mass unit? You know, if I ask you what is the Planck constant value, any one of you please tell what is the Planck constant value? Right, Joule second. That is the SI unit. Right, you are. But my question is, what is its value in atomic mass unit? So if h bar is 1, that means h by 2 pi is 1, then h is actually 2 pi. So in atomic mass unit, the value of h bar is 1. Okay. The next question is related to the earlier one. Question number 6. How de Broglie formula justifies the Bohr's postulate? First postulate. You do remember that how in your UG curriculum you have answered this question, right? So I am not going into the further details of this. Now question number 7. Calculate the value of the radius of the first Bohr orbit in SI and in atomic mass unit. Hence find the velocity of an electron in that orbit. Compare it with the speed of light. Atomic unit, what is the value of Bohr radius, which is 0.529 angstrom? What is the value in atomic mass unit? Can you tell me what is the value in atomic mass unit? Find the velocity by using the formula, and then you will see that the velocity is a very big one. Actually, it is almost 1% of speed of light. So if you do this, evaluate this problem, then you will see that the final result for speed of this electron coming in the first Bohr orbit, it is 1% of speed of light. Okay, so you have to do all these problems, okay, consulting a standard textbook. And the 8th question, remark on JJ and GP Thomson. Just JJ and GP Thomson. You have to make some remark. Okay, can you read out the passage? Yeah.
It was JJ who first showed in 1895 that the electron was a subatomic particle, and it was GP who was one of the first to show experimentally in 1926 that the electron could act as a wave. These two Thomsons are father and son. The father won a Nobel Prize in 1906 for showing that the electron is a particle, and the son won a Nobel Prize in 1937 for showing that it is a wave.
It's like, demonstrate that the equation looking exactly similar to that of de Broglie can be obtained from Einstein's two relations, but yet it is not the de Broglie equation. Why? So, Arugabal?
E equals to mc square or E equals to hc by lambda?
Yeah, mc square, not E equal to pc. P is mc, so mc square, but fundamentally pc. So E equal to PC is one relation, comes from relativity paper, and E equal to h nu or hc by lambda, that is the second relation from photoelectric effect. Now you can easily just manipulate a little bit, one or two steps, you will get very easily the de Broglie relation P equal to h by lambda. That also, if you consult my earlier class, you will get it. So this first part of the question. Then the second part, but still we are not calling it de Broglie relation, though it looks exactly the same. Why? De Broglie relation is a very general relation. It is valid for everything. So that means it is valid for light as well and electron as well. But Einstein gave only about light, that it is behaving as particle. So I called it a one-way traffic kind of thing, that Einstein could give the one way of the direction of the one way, and de Broglie made the cycle complete, right? So that also we have discussed. The next question, so that Planck's constant has dimensions of angular momentum. So that's a straightforward dimension question, you can carry it out, please. The next one, if we look at an electron to within 20 picometer, then what is the uncertainty in its speed? So it is uncertainty relation, application of uncertainty relation. Again, you can say it's a HS level question. You can get it. And if you post the answer in the group, maybe, or personally to me, I can check it whether you have done it correctly or not. The next question, there is an uncertainty principle for energy and time, delta E delta T greater than equal to h bar by 2. Now the question is, so that both sides of this expression have the same units. So again, it's a dimension related question, you can easily find it out. Next question, it's a bit mathematical, that given Z is J plus I, determine the magnitude of mod Z and the phase angle theta of Z. So it is, complex number. Z is a complex number, a plus ib kind of thing. Here a is j and b is 1, that means simply I is there, small I, imaginary number, square root of minus 1. So if Z is given like that, then you have to determine the magnitude of the number, complex number. So any mathematics students, lower class mathematics student can even say that mod Z is defined as root over a square plus b square if the number is a plus ib. So you can get it, and theta, the phase angle theta is tan inverse b by a. So here b is 1 and a is j, so you can easily get it. Okay. Why there is a typical mathematics question? Because in quantum mechanics, I plays a crucial role. It may be complex sometimes. You see that the wave functions also come as complex functions, etc. Well, the next question, what is the physical significance of a wave function or its some function?
Basically quantum mechanics say it is a mathematical representation of the wave, and psi square, which is a function of psi, that represents the probability density.
Good. Defined as mod psi square instead of psi square?
So because যদি ওখানে আমরা ইমাজিনারি কোনো ভ্যালু দিতাম, মড না থাকলে ইমাজিনারি ভ্যালু থাকার একটা চান্স থাকে, তো প্রবাবিলিটি ইমাজিনারি কি করে হবে?
Good. The next question is, what do you mean by well behaved function? Answer me.
FICS.
Right. Go on.
Finite continuous single valued আইটা কেটে গেছে,
integrable, square integrable it should be.
Very good, very good. Square integrable. So that's the answer, that it has to follow these 4 mathematical criteria. Now the next question, why a wave function must be well behaved to be acceptable? Why the necessity is there?
Property from psi.
That's okay, but more clearly
Sir, because if psi is not continuous or not finite, we won't get the probability density.
Right. That means
so it has to be it has to fulfill these conditions.
Right. So that means the basic point is that the way psi is postulated, that mod psi square is probability density, so that is the physical requirement that makes the all other 4 criteria to be important. So the answer is because mod psi square is probability density. So rest of the thing that you have rightly told, fine, okay. Okay, about psi is okay, but why, next question, why the first derivative of psi has to be continuous? Psi is okay because mod psi square it is probability density, so it has to be continuous. But why the first derivative has to be continuous? Second derivative has to exist, then its earlier one, that means first derivative has to be continuous. So I repeat, if the first derivative needs to be existing, then the function itself has to be continuous. If the second derivative has to exist, then the first derivative has to be continuous. 1 degree less, second then first, and if it is first to exist, then the function itself. Now the question, why the first derivative has to exist and why the second derivative has to exist? And for that reason we are saying that the function itself and the first derivative are needed to be continuous. So the question, why do they need to be existing? The answer is, as far as the first derivative, why it needs to exist, the answer is because momentum itself is defined in terms of the first derivative. So del x, h bar by I del x. So del x has to exist. So psi has to be continuous. This is another interpretation. And why the second derivative has to exist? Because the Schrodinger equation itself is a second order differential equation, del 2 psi del x2. So if it doesn't exist, then the whole Schrodinger equation gets lost. It loses its meaning. So because of the Schrodinger equation, it contains the second derivative, so it has to exist. So psi, first derivative of psi, has to be continuous. I think it's clear. It is a typical problem, and I have taken it from my class lecture as such. It is related to the first postulate, that wave function, acceptability, etc. And there are 5 different functions are given, and you have to determine whether each of the following functions is acceptable or not as a wave function. Indicated intervals are indicated. So it has already been discussed, and the solution is there. So in this type of question, when you have to assess whether something is acceptable or not, if you just know that, okay, I know this function is acceptable, only the logic I have to supply in my answer script, then you better give the idea that, sir, it maintains FICS, in full form, so it is acceptable. You need not explain actually or derive the requirement, mathematical requirement for each and every point. That would take a long time, and marks is not proportionate, right? So it is enough to say that I know, sir, what are the properties that it has to satisfy, and I also know that this function satisfies. But if it doesn't satisfy any one of the 4 criteria, then you have to show, or at least mention, that this particular function doesn't satisfy this particular condition. That's all. Okay. So all the solutions are given, not actually the answers are given. You cannot call it a solution in that way, because mathematically it is not showing, particularly the last, E, the last question, e to the minus mod x. It is simply saying it is not acceptable because the first derivative of the function is not continuous at x equal to 0. So how one can say that without doing a lot of mathematics? So it is here, what it is giving, it is not a solution, it's an answer, right? And I told you that anecdote or story, I am not quite sure. Okay, let me then share a story with you. Storyline is there. Would you like to listen to that story? It would give a break kind of thing also.
Yes.
Next question, are a wave function and eigenfunction necessarily the same? Explain. That also part from my lecture, that wave function who satisfies the 4 mathematical criteria, right? They are acceptable, but they may not be an eigenfunction, often given operator, right? It may be, We have seen so many examples. So this is the point, that an eigenfunction must be an wave function, otherwise why should I consider it at all? But a wave function may not be an eigenfunction of a given operator. It may be an eigenfunction of another operator, maybe, but not another operator at the same time. So next question, what do you mean by linear operator? A standard question, and Hermitian operator, that we have discussed. A quantum mechanical operator must be linear and Hermitian. Justify or criticize. So you tell me whether it is justified or in some point is that to be criticized. That a quantum mechanical operator must be linear and Hermitian.
It always shows a real value, a Hermitian operator.
Good.
So a quantum mechanical operator should give a real value.
Right.
So that's why it should be Hermitian.
Why it should be real? There is another sort of value, complex. What's wrong if it's complex?
So in complex value, there should be some imaginary part.
Right.
So that's why in quantum mechanics, imaginary is not valid. So it should always have some real value.
Not really. The words you are using, that in quantum mechanics imaginary is not valid, then I is there. Why I is there? Or momentum operator is h bar by I. So I is already there. It's not that it is not valid. Actually, want to mean that when an eigenvalue is complex, and what is an eigenvalue? It is an value of an observable, measurable quantity, right? And that is the point, that any value which is an value of some property, observable, measurable property, that cannot be complex. I gave an example that your age, can it be 20 plus 7i? Do you ever say your age is 20 plus 7i? Or length of a tree, 5 feet plus minus 3i? We never say. You cannot find any observable that you are saying its value in complex number. That's a simple daily life requirement. Okay, it's not that in quantum mechanics there is no imaginary number. Fine. Is it clear now? I discussed in my class that define a Hermitian operator using a standard and bracket notation. So in a standard notation you have to give it, and also in the bracket notation. Next question, mention two important properties of a Hermitian operator. So one already have mentioned, right? The eigenvalues are always real if the operator is Hermitian. And another property, any other property?
Functions of the Hermitian operators should be orthogonal.
Very good, very good. The eigenfunctions of an Hermitian operator are orthogonal. Slight catch is there, if they are non-degenerate eigenfunctions, then they are of course orthogonal. Okay, non-degenerate functions. But what happens if they are degenerate? Then I discussed that even then it can be made orthogonal, and I discussed the Smith orthogonalization method for that. Maybe I have not discussed in depth, but it is there in the PowerPoint, you will see. So you are right. So we have got two important properties, orthogonality and real eigenvalue. Next question, define a commutator and how is it related to uncertainty relation. So that we have discussed a number of times. The next question, can you quantitatively determine the uncertainty relation by using the commutation relation? So that is something new. Question, what do you mean by orthonormal set of functions? Give example. Orthonormal set of functions. So if
Na, sir.
Bokochop, na. Is there anyone who has heard the word Bokochop? Anyone?
Yes, sir.
Tell me.
Yes, sir.
Probably in. Yes, sir.
Tell me what it is. Where you have heard it?
Sir, in some poetry.
Written by whom?
Kumar Rai.
Very good. Sukumar Rai. Bokochop is peculiar. Bok and Kochop taken together, and it's a very very awkward and unique creation. The animal, which is partly Bok and partly Kochop, and taken together we call it Bokochop. So why I am referring to that? Because orthonormal is that kind of Bokochop. It is, you know, when a set of functions are orthogonal to each other at one hand, and on the other hand, each of the set is normalized itself. Normalized. So when each of the functions of a given set each are normalized and mutually they are orthogonal to each other, then we call the set of functions orthonormal set of functions. Right. Now, do you have any example, ready-made example for that? You know particle box, and just few minutes back we have seen that the Hermitian operator, they produce the orthogonal set of functions, right? So Hamiltonian is a Hermitian operator. So naturally its eigenstates, they are going to be orthogonal, and you can easily check that. What are the functions for one-dimensional particle in box? Root over 2 by L sine n pi x by L, where n is 1, 2, 3 dot dot dot. So if you take any m and any n, two different functions, and they are non-degenerate, so it is valid that they will be orthogonal. So you can easily take the integral psi mx psi nx dx minus L by 2 to plus L by 2, and if you do the integration, you will get 0 for any m and n when they are different, right? And if they are same, then you will get, of course, 1 normalization, because psi mx, that means psi mod square, right? And that would be 1 because you are taking the normalized function. Root over 2 by L is the normalization constant. So you have got the example, right? The next question, so that under what condition time dependent Schrodinger equation leads to time independent equation, and as it is shown that this is the expression for time dependent Schrodinger equation, and under what condition, you know the answer that I have discussed in the fifth postulate, that when H itself is time independent, then you can, taking the product, the psi as a product of psi x and something like this, e to the minus I t by h bar. So the psi xt is a function of two variables x and t, but you can decouple them as a product of two separate functions. One is of completely x and independently x, and another is of t. No x is here, and here no t is there. So you can take as a product, provided if H itself is time independent. Okay. So this time dependent equation leads to two equations. One is this, another is this. T dependent. The first one is nothing but time independent Schrodinger equation. So that means time independent Schrodinger equation is the most general equation, and what we start with in UG curriculum is a time independent, but that is a special case of time dependent equation. When H itself is time independent, then one can show that how it gives, taking as a product and then dividing both sides by psi x. It is there in my PowerPoint file earlier. Okay, you just consult that. Then one part comes out is this, and the other part comes out is this, and this is nothing but the time independent Schrodinger equation. Clear? Set of questions are related to the same kind of question actually. State the postulate 2. The second postulate. The framing is slightly gondolar. The second postulate could be the better framing, and use it stepwise to find the Hamiltonian of a PIB and an SHO system. So what really I want here, can you tell me? So is it clear to you that how you can use the second postulate to construct the Hamiltonian for any given system? Actually, you have handled this, in UG curriculum you have handled, but maybe without knowing much that why you are doing so. You have done it just to do it, right? But in this PG classes, actually we are going slightly deeper to understand that why you have done so, because of the second postulate and because of these 3 steps. So is it clear to you? Please do practice this part and consult the class note. Well, the next question is, why solving SHO problem is not as easy as that of the PIB problem? It's a very different kind of question. You have tackled the wave functions only, energy expressions only for SHO. It is just because the presence and absence of Vx in these 2 problems. Clear? Well, the Next question, state the third postulate of quantum mechanics and explain it. Explain means just you have to tell one or two words that what it's all about. Similarly, state the fourth postulate of quantum mechanics and explain it. And similarly, state the fifth postulate of quantum mechanics and explain it. So that we have discussed in details. The next question, what do you mean by stationary state wave function? So stationary, clear, stationary state, or should I repeat? The probability density as well as energy does not change with time is called the stationary state, and that is you can easily show if, of course, the Hamiltonian itself does not contain any explicit time. Otherwise, it may depend on the time. Okay. Next question, state the sixth postulate of quantum mechanics. How is it significant? So that is the same type of question I have discussed. What do you mean by antisymmetric wave function? Demonstrate in determinant form for a 2/2 case. So that I have, this is something new for you, I know, and I have discussed in details that this is connected to the sixth postulate, which is really new because in undergraduate level we never come across this postulate. Though in inorganic part somehow we get in touch with this concept, but not in quantum syllabus in physical. Anyway, in our case we have discussed in depth, and we have demonstrated by taking a 2/2 case, that is helium two particle system. So that's why it's a 2/2 case. Please consult the class note. And the last question of this slide, relate Pauli exclusion principle and antisymmetric wave function with a 3-electron system. So in the next slide in that class, it was discussed the lithium case, and 2 columns became the same, identical. That's why it vanishes. So there doesn't exist any wave function. All these things, and how the concept of Pauli exclusion is all about in terms of determinant, what we are saying. Okay, so that also was discussed in the class note. Next slide. Okay, this is taken from my class note, so I am not repeating, only just mentioning here as separately as question. This is nothing but doing a normalization integral, very easy. This is a typical question as well in a UG level, and this is something I have also discussed, that you have to evaluate this, you have to evaluate that, and hence using this and another starting equation you have to state and prove the Ehrenfest theorem. So this is typically that part of that class note where I have discussed the Ehrenfest theorem. So no shortcut, only that this evaluation, it may take some time. So preferably in my own style, maybe that I will be providing this commutator value and will ask you to find last part, that Ehrenfest theorem, so that it may save your time for evaluating. Or if you remember that Hx equal to this and Hpx is this, but I can't expect that each and everyone will remember all these peculiar values. So it is better not to give for evaluation. But Ehrenfest theorem is very important. So if the commutators are available, then it can be set as a good question. And mention its significance. So significance, as I told you, that it demonstrates the superiority of quantum over classical. And as I told you that it's a one-way traffic. That means from classical you cannot reach to the quantum conclusions, but from quantum in some special cases you lead to the classical results, and that is itself Ehrenfest theorem, because we get 2 quantum versions of Newton's equation, one involving I think momentum, another involving energy and potential energy, force, right? So I think you do remember the last part of that slide, that presentation. And then these are typical questions taken from my class notes. What do you mean by constant of motion? And this is a question given in that slide, along with the answer. Here the answer is not there. And how one can determine whether 2 wave functions are distinguishable or not. Give example. So two examples are two wave functions are distinguishable or not. The criteria for assessment is what? Mod psi square, whether they are same or not. That I also discussed, taking an example or through a problem. You know, do you remember sine square kx kind of thing? So one wave function was sine kx, and a set of functions were given as psi x, and in that case, in my example, all those psi x were given in such a way that if you take the psi square or mod psi square, then all give the result sine square kx. That means it is the same as to that of the given function, mod square of the given function. So they are all indistinguishable. So any example means you can take one example from that problem itself, or you can give any other problem as well. Demonstrate with example of PIV problem, Bohr's correspondence principle. So I also explained that what is Bohr's correspondence principle. That means in the higher limit of quantum number or energy or momentum, the quantum gives you the classical result. For example, if you take the delta E n to n plus 1 divided by the energy of nth level, that means the relative separation of the consecutive levels, then it can be shown that for expression it comes for very big n, the result in the limiting case when n tends to infinity, the result tends to 0. That means the consecutive relative difference between the energy levels is 0. That means continuous. So quantum effect, that is quantization, it gets lost. It gives you practically the continuous spectrum, and that is the classical result. So that is what I mean by Bohr's correspondence principle demonstration through the example of energy of particle in box, more precisely relative energy gap up to consecutive levels, and the mathematical part is already there in the slide, in my class slide. So these are the few questions taken from my slides. One is regarding probability on the 1/3 of the box, and then the average position involving harmonic oscillator, and the most likely position. That is, one is a differentiation problem, another is integration problem that I discussed in my class. And also the last one briefly mentioned the similarities and dissimilarities between particle in box problem and SHO problem. That also is noted clearly point wise in my class note. Okay. So again, this is a question from my class as such, so I'm not discussing it anymore, but this is important when we expand a function in terms of the eigenfunctions, then that expanded function may not be eigenvalue. So in that case we do averaging, but that averaging you can say that it is going to be one of the eigenvalues of those eigenfunctions in terms of which we are expanding the new function, but we are not quite sure that which eigenvalue it is going to be. Then we discussed the thing, and the problem was then given along with the solution, and the answer is here also. That I do remember. I think you do remember this problem I discussed in details. So what do you mean by classically forbidden region? I explain with diagram with reference to a particle in a finite depth problem. The diagrams are also there in the slides. Briefly explain the tunneling through a barrier. Also explain with a suitable diagram of SHO, the last few slides of that last class, and find the tunneling probability for a quantum mechanical SHO ground level. Also you can skip some of the mathematical portions of that problem, but it is there in our outline is there in my slide, and give example of two real life problems where tunneling theory helps to explain. So one is chemical reaction, another some decay I have not mentioned. The radioactive decay is also one such example. A reaction is example, and of course tunneling microscope is another example. So with this much, let me end today's review part. So thank you very much for patiently listening, and now we can spend a few minutes more if you have some queries or whatever it is.
सावन भी तो जाए पिहरवा, मन मेरा घबराए, मन मेरा घबराए। ऐसो गए परदेस पिया तुम, ऐसो गए परदेस पिया तुम, चैन हमें नहीं आए, चैन हमें नहीं आए। मोरा सैया मुझसे बोले ना, मोरा सैया मुझसे बोले ना। मैं लाख जतन कर हारी, लाख जतन कर हार रही। मोरा सैया मुझसे बोले ना, मोरा सैया मुझसे बोले ना। ऐसो गए परदेस पिया तुम, ऐसो गए परदेस पिया तुम, चैन हमें नहीं आए, चैन हमें नहीं आए। मोरा सैया मुझसे बोले ना, मोरा सैया मुझसे बोले ना। सावन भी तो जाए पिहरवा, सावन भी तो जाए पिहरवा, मन मेरा घबराए, मन मेरा घबराए। मोरा सैया मुझसे बोले ना, मोरा सैया मुझसे बोले ना। ऐसा।
বাহ, রীতিমতো ভালো। তোর তো বেশ তৈরি গলা, মানে বোঝা যাচ্ছে ইউ আর ইন প্র্যাকটিস, ইউ আর ইন টাচ।
থ্যাংক ইউ স্যার।
ভেরি গুড। এটা কি রাগে?
স্যার এটা খামাজ আমার যতদূর মনে
খামাজ।
হয়।
আচ্ছা আচ্ছা, থ্যাংক ইউ ভেরি মাচ অপূর্বা।
থ্যাংক ইউ।
অপূর্ব, অপূর্বা। So who is অরিত্র?
এই বুঝি তোর, এই বুঝি তল পেলে ফের হারালে, প্রয়োজনে ডুবে যাও, গভীরে যাও, আরো গভীরে যাও, গভীরে যাও, আরো গভীরে যাও। এই বুঝি তল পেলে ফের হারালে, প্রয়োজনে ডুবে যাও। জানলা জুড়ে মানুষের কান, গলির ভাজে ভ্রমরের প্রাণ, গণিকার গান লেগে থাকে তার ডানা, আর অন্ধকারে ছটফটিয়ে মুখ ফেরানোর দায়, তার উড়ে আসা ধূসর চোখে সিগারেটের ছায়। তাই গভীরে যাও, আর গভীরে যাও, গভীরে যাও, আর গভীরে যাও। এই বুঝি তল পেলে ফের হারালে, প্রয়োজনে ডুবে যাও। থ্যাংক ইউ স্যার।
Now it's
ঠিক আছে স্যার।
পৌলমী। start.
কতবার ভেবেছিল আপনা ভুলিয়া তোমারও চরণে দিব হৃদয় খুলিয়া কতবার ভেবেছিল আপনা ভুলিয়া তোমারও চরণে দিব হৃদয় খুলিয়া চরণে ধরিয়া তব কহিব প্রকাশী গোপনে তোমার সখা কত ভালোবাসি ভেবেছিল কথা তুমি স্বর্গের দেবতা কেমনে তোমারে কব প্রণয়ের কথা কতবার ভেবেছিল আপনা ভুলিয়া তোমার চরণে দিব হৃদয় খুলিয়া ভেবেছিল মনে মনে দূরে দূরে থাকি চিরজন্ম সঙ্গ পালে পুজিব একাকী ভেবেছিল মনে মনে দূরে দূরে থাকি চিরজন্ম সঙ্গ পালে পুজিব একাকী কেহ জানিবে না মোর গভীর প্রণয় কেহ দেখিবে না মোর অশ্রু বারিচায় আপনি আজিকে যাবে শুধাইছ আসি আপনি আজিকে যাবে শুধাইছ আসি কেমনে প্রকাশী কব কত ভালোবাসি কতবার ভেবেছিল আপনা ভুলিয়া তোমার চরণে দিব হৃদয় খুলিয়া তার গলাটা বসেছিল পুরো ঠান্ডা লেগেছে
এক্সেলেন্ট, ফ্যান্টাস্টিক। দাদা ভুলভ্রান্তি কোথাও কিছু হয়নি, মানে আমার কানে অন্ততপক্ষে লাগেনি।
দ্রুত গতিকে মিস করছিলাম।
হ্যাঁ, দ্রুতগতটা ভালোই তো, তিন তালের উপর আমার মনে হলো। হ্যাঁ, ভেরি গুড। বাহ, তোদের গ্রুপে তো অনেকেই দেখছি অনেক কিছু, আসলে আরো অনেকে আছে, মানে এক্ষুনি আবিষ্কার করা যাচ্ছে না হয়তো, আরো কেউ কেউ আছে নিশ্চয়ই। ভেরি গুড, থ্যাংক ইউ অল ভেরি মাচ ফর প্রেজেন্টিং এ নাইস আফটারনুন। পরে যদি সুযোগ পাই কোনোদিন আবার শুনবো, ঠিক আছে? তো সো বেস্ট অফ লাক, উইশ অল দ্য বেস্ট, থ্যাংক ইউ। বাহ, ভেরি গুড। তুই এখনো প্র্যাকটিস করিস তাই তো, মানে রীতিমতো বাজাস নিশ্চয়ই, আই থিঙ্ক সো। সো থ্যাংক ইউ ভেরি মাচ, থ্যাংক ইউ।